Welcome back, everyone. To round out our section on routing on Azure, we're going to take a quick look at a newly added managed service called Azure Route Server. Quick bit of history, this service actually became generally available very shortly after the AZ700 exam was first released, and as such, it was a little bit of a last-minute addition to the current exam objectives. This lesson is purposely going to be a quick high-level overview focusing on a few specific points when it comes to implementing Route Server you need to be aware of. In this quick lesson, we're going to take a quick look at the primary purpose of working with Azure Route Server, and we are also going to discuss how to implement the service as well. So jumping on into it, let's talk about the purpose of using Azure Route Server, which basically comes down to the ability to have another managed service automatically create custom routes over Border Gateway Protocol for different virtual appliances. In other words, this managed service doesn't do anything that you can't do on your own when it comes to creating routes. It just does it for you automatically so you don't have to. Now, quick point to be aware of is that the Azure Route Server service is specifically designed for routing between virtual networks and network virtual appliances, which again typically uses the acronym of NVA. Virtual appliance examples include either a firewall, an SD-WAN gateway, or even a manually created load balancer service. With that in mind, the Azure Route Server service can also be used with virtual network gateways such as VPN or ExpressRoute connections. The main benefits of using Azure Route Server again come down to automatically creating and managing custom routes for you. For example, in a large network implementation in which you periodically add and remove subnets from your virtual network infrastructure, when properly configured, Azure Route Server can automatically create new routes and discover and associate new subnets for you. And also, like most managed services on Azure, this is a fully managed service and highly available for redundancy, and you also have the ability to peer multiple virtual network gateways or virtual appliances with a single route server instance as well. Keep in mind, however, that these virtual appliances must support BGP in order to peer with Route Server. So let's go ahead and take a quick look at an example route server diagram to get a better idea how this service works. In this example, we have a sample virtual network in which we have a subnet of several virtual machines on the left side. In the middle, we have our Azure Route Server service. That's that ARS yellow icon that you see there. And on the right side, we have another subnet which houses a network virtual appliance. In this case, it's going to be a firewall. For our setup, we'll configure Azure Route Server to peer with our network virtual appliance over BGP. And then once Route Server is peered, or in other words, associated with our virtual appliance, Route Server will then automatically detect and update routes in its scope. By default, that scope is the same virtual network the Route Server service itself is deployed to, although you also have the option of remotely peering with other virtual networks outside of its own VNet as well. In either case, the Route Server service will automatically detect subnets in its scope and then automatically create new effective routes on your behalf. In this case, it will automatically create a user-defined route of all zeros, which will be internet-bound traffic routed through our virtual appliance on the right side. Again, this is the exact same process of creating user-defined or custom routes, except this service is automatically detecting and creating those routes so you don't have to. Next, let's take a quick look at how to implement the Azure Route Server service. And these are going to be the specific points we are going to focus on, at least from an exam perspective for this lesson. Our first step will be to create the Route Server service, and very important to note is that this service requires a dedicated subnet, which once again goes back to our previous lesson on subnet delegation. That subnet must have a specific name of Route Server subnet, and inside of that very specifically named subnet, you'll deploy the service. After Route Server has been deployed, you will then peer or associate Route Server with your network virtual appliance, which will be accomplished over BGP peering info. If you're familiar with BGP, that uses associating an ASN number with your virtual appliance and the peer IP. And then the final optional step, if you are working with a virtual network gateway associated with Route Server service, you will then configure route exchange between Route Server and your network gateway, again, if you're working with VNets, VPNs, etc. So that's going to wrap up our, again, very quick lesson on working with the Route Server service. It was a purposely high-level overview, focusing on some very specific points, mostly related to subnet delegation and the Route Server subnet naming scheme. Let's quickly review our key takeaways before we move on. We started by learning about the purpose of the Azure Route Server service, in which it is able to automatically create and update routes between associated subnets and network virtual appliances or virtual network gateways, and we also learned it works over the BGP protocol. We then covered the high-level overview of implementing a route server, which includes creating a dedicated subnet with a specific naming scheme of route server subnet, from which we will then create a peering connection over BGP between route server and our virtual appliance. That's going to go ahead and wrap up this lesson. Let's go ahead and move on to the next one.